Hello dear students, this is Mr. Ezzat Muhammad. Today we are going to revise topic 1, forces and motion. The first part of this revise is available on my channel on YouTube and platform. I will leave the link in the description below. In this session we are going to revise acceleration, speed, time graph, and finally we are going to revise mass, weight, and density. So let's get started. First, the definition of acceleration. What is acceleration? Acceleration is defined as rate of change of velocity. Rate of change of velocity. We are using this blank formula to find acceleration. A equals delta V over delta T. Okay, acceleration is simplified to A. Rate of change of velocity is simplified to delta V. Delta V equals final velocity, which we name it VF, or we call it VF, subtract from initial velocity, which we name it VI, initial velocity. All of this is divided by delta T. We use meters per second square to measure acceleration. So the definition of acceleration is rate of change of velocity. Our blank formula we are using in solving question is A equals delta V over delta T, which is equals VF subtract from VI divided by delta T. Meters per second square we are using to find acceleration. Okay, we have a negative side of acceleration called deceleration. This happens when speed is decreasing, by the time. Okay, let's move into the other part, which is displacement time graph. When you have distance on the vertical axis measured by meters and time on the horizontal axis measured by second, the slope or the graph represents velocity. Slope here equals velocity. Okay, so the displacement time graph represents velocity. The kind of velocity depends on the curve. This red line or this straight red line represents a steady velocity, or a constant velocity. This happens when the velocity increases. The red line and this green line also represent a steady velocity. When the velocity or the speed is increasing. The second part of the curve represents a stationary velocity or speed. It will be always parallel to the horizontal axis. This is a stationary speed or velocity. The third part of the curve represents a steady velocity returning to the starting point. This happens when velocity or speed is decreasing, like or such as he was moving at the speed of 5 meters per second at the first second. Then he moves with a speed of 2 meters per second. Notice here that the velocity or the speed is decreasing by the time, represented by straight line to down, straight line to down, straight line to up represented a steady velocity, straight line to down represents a steady velocity returning to start. Okay. Displacement and time. The object here is accelerating when the line is curved and the gradient is increasing. The gradient is increasing. The object is accelerating. The object is deaccelerating when the line is curved and the gradient is decreasing. Gradient is decreasing. This is the starting point 0.0 and the object is moving to, or the object is deaccelerating. Okay. To find the slope or the speed, which in this case equals speed or velocity, we are going to find it from the gradient. Gradient equals change in y over change on x, or change in vertical axis over change in horizontal axis. Such as if we had here 5 meters and 2 seconds. To find the gradient or speed or velocity in this case, we are going to divide 5 meters by 2 seconds. Okay, velocity here is going to equal 5 over 2, which equals 2.5 meters per second. Don't forget to write the unit of measuring. Okay, let's jump right into velocity time graph. Velocity on the vertical axis and time on the horizontal axis. This graph represents acceleration. Slope here equals acceleration. To find the acceleration from the gradient, acceleration is going to equal or equals change in x or change on y over change in x, or change in vertical axis over a change in horizontal axis. We are going to take 8 over 2 change in y equals 10 or 8 over 2 acceleration here is equals 4 meters per second square. If you want to find or calculate the acceleration from the graph, a change on y over a change in x. Okay, the kind of acceleration here depends on the curve. The red line represents a constant acceleration. And what is a constant acceleration, or what is the definition of constant acceleration? Constant acceleration is equal speeds with equal times. Equal speed distances with equal times. The red line and the green line also are representing a constant acceleration. So the red line and the green line, both of them are representing a constant acceleration. The second part of the curve represents a constant velocity. Constant velocity parallel to the horizontal axis. The third part of the curve represents a constant deceleration. What is the definition of constant deceleration, or what is the constant acceleration? Constant acceleration happens when the speed is decreasing over the time. The speed is decreasing over the time, or the velocity is decreasing over the time. To define the constant deceleration, we can say that constant deceleration is unequal distances with or in equal times, unequal distances in equal times, unequal distance in equal times. So when you see velocity on the vertical axis and time on the horizontal axis, that means the slope here equals acceleration. To find it from this graph, you are going to divide horizontal axis or vertical axis, any number on the vertical axis, over the number of horizontal axis, and don't forget the unit of acceleration, meters per second square. Acceleration here, like I was saying, equals the gradient equals change on y equal to change on y over change in x. Something you should keep in mind: area under the graph gives the distance traveled. Area under the graph gives us the distance traveled. Take a look at the following example. We have velocity on the vertical axis and time on the horizontal axis. That means slope here equals acceleration. Okay. The area under the graph, this area under the graph represents or is representing a distance. To find the area under the graph, we are going to find the area of the triangle plus the area of this shape. Okay, the area of the triangle equals half times the base times height, half times the base times the height, plus the area of this shape, which equals base times height, or plus the area of the square, base times height. For example, if the area of the triangle equals 5 meters square and the area of square equals to 10 meters square, the distance here is going to be 5 plus 10, that gives us 50 meters. Or the distance traveled here is 15 meters. Okay, let's move on to the next part. The motion of object falling, or as we name it, as we call it, free fall. Free fall acceleration is a change from A to G, from A to G in free fall. Okay, G here equals approximately 9.8 meters per second square, but this value only in free fall. A equals G equals approximately 9.8 meters per second square. Object free falling in uniform gravitational field area R, or R in the absence of air or liquid resistance. Take a look at this following example. This is a man free falling from a helicopter. To calculate force here, or force or gravity, V gravity equals 933 N, or Newton. Force of air, the second part, force of air